Okay, so we started off by factoring that, and this thing we pulled out, what was this called again? GCF. That's a GCF. You always look for that first. So problems that used to be just like this, and you would have factored it, you know, like right away, they're not going to look like that. They're going to look like this. 2x squared plus 4x minus 6. Do you get what I just did to all of those terms on the top? There was a 1 here, now there's a 2. There was a 2 here, now there's a 4. There's a 3 here, now there's a 6. What did I do to everything? I doubled it. I times it all by 2. So a problem for today is going to look like this. And the first thing you got to do is find the GCF. What's the GCF? 2. So the 2 comes out. And then you write down what you have left. I'll use the dice so it doesn't feel like I'm picking on anybody. Even though I do call on students from time to time, I'll let the dice call on students for a bit here. Row 6, that means it's down to 2 people, and even and odd, it's the even ones, so that's you, Nico. What's left after I factored a 2, which is like dividing by 2 on everything? What'd I get left? Yup. Perfect. Now factor it again. So that 2 came out, and now I got 2 sets of parentheses. So it's like factor, now factor again. And you should see how ridiculous these get in my honors classes at like honors pre-calc, which is like really hard class. We'll sometimes have to factor it 5 times. You factor it once, then you factor something else out, and then you factor something else out, and then you factor something else out, and then you got to factor one more thing. My point is that don't be surprised that there's 2 things you have to factor, because seriously, when you get good at this, there might be 5 things to factor. All right, so first I've got this 2 factored out, and that was called the GCF. And that stays there. Don't just like throw it away. I got the 2 there. And now I have an x, and I tell you this is a 3-step process. The first step is just writing those numbers. The second step is what signs to use. Can I use a minus and a minus? No, I can't. Know why? Because I need this to come out negative, and a minus times a minus wouldn't give me a negative 3. So one of these has to be plus. It doesn't matter which one. Just pick one and make it a plus. See how that's the second step? First step is x and x. Second step is plus and minus. And then there's just one thing left. How do you make a 3? 3 times 1. And you can put it anywhere. It doesn't matter. So I'm going to put it here and here. And I'm going to just see if it worked. This is the part that's so critical. Yeah, there's first, outside, inside, and last. But it's these 2, the outside and the inside, that will tell you whether you really did it right. Negative 3x and positive 1x adds together to make negative 2x. Dang, I was close. But let me show you why I wasn't right. I wanted positive 2x. I'm getting negative 2x. Whenever you get the exact opposite of what you wanted, then you switch just the signs. Not the numbers, but the signs. So my signs were messed up. And this should be x minus 1. I didn't need to erase the x there, but there. And this should have been plus 3. And there we go. Because now it's positive 3x and negative 1x, and that makes positive 2. That's how you do today's. Is that the hardest there could ever be? No. Want to see the hardest there could ever be? Okay, here's a typical difficult one. 2x squared plus 3x plus 1. But wait, I'm going to times them all by 10. 20x, 30x, and 10. Anytime you see that the numbers are all really big, like 20, 30, and 10, you got to go, oh, I guess there's something in them all. There's a GCF in them. So right away, some of you noticed, all you did, Mr. Server, was multiply them all by 10. So what's the GCF? 10. So everybody factor out the 10 and then factor it again. This is as hard as they can be, and we're already there after just a few minutes, which means today is mostly just practicing factoring. This is definitely something you got to get good at. If you think about like shooting a bow and arrow, you can watch somebody do it, and after you try it once, you might be able to like get the arrow to go somewhere. But after you've done it like 100 times, you're going to be way better. Seriously, you're going to factor way more than 100 times just this year. And next year, you'll probably factor 400 times. Seriously. It's that big of a deal. That's why we got to get good at this. All right, so when I took that 10 out, it was like dividing this by 10 and dividing this by 10 and dividing that by 10. And that'll tell me what to put in these 3 spots. This spot, and this spot, and this spot. And then I'll factor it again in a second. But first, I'm just factoring out the 10. That gives me 2x squared plus 3x plus 1. Don't try to do everything at once. Just factor out the 10, and then you can break it in 2 parts. 3-step process. Jack, what's the first thing I do for the 3-step process?
Put in the x's.
Yep. Would you agree it's a 2x and an x? To be able to get 2x squared, I needed a 2x and an x. Now, is it a plus and a minus? Plus and a plus? Minus and a minus? Plus, plus. Good. Okay. Amelia, how do you finish the deal? 1 and 1. And that feels like the only thing it could be, but you've got to check it. What do you get on the outside ones? E and A, what do the outside ones give you?
3x.
Just the outside ones.
3x.
Nope, the outside. 2x and 1 makes, multiply them.
2.
2x. And then this one makes 1x, and then together they make 3x. Yes. And that's what we wanted, was 3x. So yay, I did it right. And then if they really wanted to make this a beast problem, they wouldn't have said factor. They would have said solve, which just means one more little thing. That has to equal 0. X plus 1 has to equal 0, so x equals negative 1. And this has to equal 0. Everybody please solve that last one. And that is as bad as they could possibly get for factoring. Now, if you want to make them scarier looking, then you add a word problem around it. But still, it's just going to be an equation you have to factor. But if they said, you know, like on Jim's farm, he realized that if he set up this certain equation, that he could find the 2 possible like numbers of chickens that he could raise that would bring him the most profit. And it was this equation. And then, boom, you get an equation like this. And then you solve it, and then you get the answer. And it's just the same exact thing. It's just got context. Oops. Divide by 2, divide by 2. And then I get x equals negative 1/2. Who had 1/2 before? I did. Awesome. Negative 1 and negative 1/2 were your 2 answers. And that had a GCF in it that you factored out first. Okay, so this title of this thing was using GCF and another method. So you always take the GCF out first. All right, here's some other ways we have learned to factor. Did you learn this pattern the other day? I know the answer already. It's just like a little pattern I'm used to. In real life, you notice patterns all the time. Like, oh, there's this one kid who's late every time. You know, one of my hours, I have a kid who's just late all the time. In another hour, there's all kinds of patterns that I notice. These 2 kids just always are talking when they shouldn't be talking in class. Not in this hour. I'm not actually complaining about that. So my point, there's little patterns you notice. And this pattern was that this is an x and this is an x because it's like splitting up the x squared. And then if you split up the 100 into what? 10 and 10, and then you just got to know what to put in between them. Plus and a minus. There it is. That's the little pattern for that kind. All right, so how would we make that kind harder? With a GCF. Let me show you. 2x squared minus 200. And you got to notice that, oh, they both have a 2 in them. That's called the GCF. So you factor out the GCF. And now it's just x squared minus 100. And my gosh, we just did that one. So all that was different is it had a GCF. And then it's the same exact thing, x, and a plus, and a minus, and a 10, and a 10. That is called difference, because minus is a difference. Plus is the sum, you know, this is a difference of squares, because that's a perfect square, and that's a perfect square. Okay, I think I'm ready to just fly through these notes. Factor out the GCF. Everybody factor out the GCF on this one. If you're thinking 3 goes into both of them, you're right. But there's something else. Don't just factor out the 3. Amelia, what else besides a 3 would factor out? Yes. And if you ever wonder what goes inside, frankly, you'll grow out of this, but if you're not good at finding the inside of these, just divide by 3x. You don't have to do this. It's like a crutch. But if you're not knowing what to put inside, that'll tell you. And x squared over x is really just x. There. And this is really just 6. And there was a minus. There it is. Raise your hand if you had that one right. Cool. Difference of squares. Well, they're both perfect squares. So, factor them both. I know, it's different than the last one, but that's what I'm here for. Keep on showing you all the different ways you could factor. Well, I don't know what to do with the x and the x. Well, that's a good start, but how do you make it 36? 6 and 6. Good. And the 100 splits up into the 10 and the 10. Then you got a plus, and then you got a minus. Boom. Now, this is one of those where it's frustrating for kids because they do this on the test and then it's wrong. And I'm going to show you a way to never have this happen to you. You got to think like, is there something else that can factor? I'm going to ask you that on the test to look at all your answers and say, is there something else that can factor here? Do you get that these both have a 2 in them? Then you have to factor that out, or you haven't factored it all the way. Do you get that these both have a 2 in them? So get the 2 to come out here, and get the 2 to come out here, and then you'll be done. Pause for a second. Okay. This one is brutal. They call it brute force. Just because you have to like go through a ton of different choices. You know why? Because 60 can be made with like 8 million things. So take my advice and do the 3-step thing. Put in x's, and then you think about the signs. Is it minus minus or plus minus? I mean, there has to be one minus at least, right? Yep, a plus minus or a minus plus. It doesn't matter which order, but I have 1 plus and 1 minus. And now, oh my gosh, 60, there's like a million choices. We might have one like that on the test, and you got to go through all of them and figure it out. But just fail fast. If you want to, the kids that are super organized are going to make a list like this. 2 and 30, 3 and 20. These are all things that multiply to 60. 5 times 12, you'd have a calculator, so you could like verify that. 6 and 10. Does 4 go in? Yeah, 4 even goes into 60. So 4 times something. 4 times 15. Oh my gosh. Okay, so you go through each of them and you see, did you get it or not? So I'm going to do, would you agree that 30 and 2, there's no way that's going to make a 4? There's no way that's going to make a 4, so I'm just crossing them off. Because I know that when I do that one multiplied out. What else looks like it could make a 4? 20 and a 3, are they going to make a 4? No. 5 and a 12, are they going to make a 4? 5 and a 12 could make a 7. But 6 and a 10, ooh, dingo. See what I mean? This is called brute force. You just go through all of them and you go, it's got to be the 6 and the 10. But the question is it x minus 6 and x plus 10? Or is the other one the right one? Well, you check. And if you get the opposite of what you want, then you switch the signs. I'm checking this one, and I'm getting 10x, and I'm getting negative 6x, and that makes positive 4x. Ooh, I wanted the negative 4x. Don't switch everything. Just switch the signs. Just switch this minus to a plus, and switch the plus to a minus. Bingo. Now that's negative and that's positive, and the total is negative 4x. Okay. This is one of those things that all you have to do is practice and you will get good at it. But you won't get good at it unless you actually multiply them out. Like if you don't check, if you just like, oh, I think that's it, you can't get good at this. You've got to check and see if you're doing it right. I went to relearn calculus because I had to pass this big math test to become nationally board certified as a teacher. It's really hard to do. Only about 1% of your teachers are nationally board certified. So to get board certified in math, I had to pass a test that would mean basically anything that high school has, I could teach it and be good at it. So I had to pass the calculus part, which really sucks because I hadn't taken calculus in literally like 28 years. So I had to go back and relearn calculus. So I would do problems and then I'd be like, so did I do it right? And there was no key. I had a worksheet with no key. And it was just so dumb because like, I think I did it right, but I don't know. At least on these, you can tell if you did it right. You just have to multiply them out. Calculus, much more complicated. You can't just multiply it out to see if you did it right. So here I would have multiplied it out and got negative 10x and positive 6x, and I would know that those make negative 4x, so I know I did it right. All right, cool. That's what this stuff is like, and this is the part where we can go directly to the homework so that when you come back from lunch, we have lots of time to work. So let us find the homework. I think it's a worksheet. All right, then I will get it posted by the time you guys come back from lunch. Okay, so we printed off the worksheet, which if you're homesick is online, and it's got 15 factoring problems. And that's all we're doing for the rest of the hour is working on those factoring problems in small groups. That's all I got for the video for today.